Question number 22. Figure shows a parallel plate capacitor with plates of width B and length L. The separation between the plates is D. The plates are rigidly clamped and connected to a battery of EMF V. A dielectric slab of thickness D and dielectric constant K is slowly inserted between the plates. Calculate the energy of the system when a length X of the slab is introduced into the capacitor. What force should be applied in the slab to ensure that it goes slowly into the capacitor? Here, this is dielectric slab whose portion X is inside the capacitor, and the remaining portion, this L minus X, is without dielectric. So we have to consider it as two capacitors connected in parallel, and then we will calculate the energy stored, and then we will try to find out the force that will ensure that this dielectric moves slowly inside the capacitor. So consider first part. So area of the portion inside the capacitor is, suppose it is A1. So X and width of the capacitor is B. So that is Bx. And suppose capacitance of this portion we try to find out. Suppose it is C1. So that will be equal to K times dielectric constant times epsilon naught times area. Area is Bx divided by separation is D. Now, capacitance of remaining portion, so will be C2 equal to epsilon naught and L minus X times B divided by D. These two capacitors are connected in parallel. So total capacitance C will be sum of the two, C1 plus C2, and that will be equal to K epsilon naught Bx divided by D plus epsilon naught L minus X times B divided by D. So if we simplify, we will get epsilon naught B divided by D times L plus X times K minus 1. Now energy stored. Energy stored of capacitor. Energy stored in capacitor is given by half CV square. That is U equal to 1 by 2 CV square. So capacitance is this much. So 1 by 2 epsilon naught B upon D times L plus X times K minus 1 times V square. Now consider second portion. So for second portion, let's delete this all. Now let force F is applied to ensure the motion of dielectric in smooth way. So when force F is applied by the electric field, then opposite force needed must be equal to and opposite to this. So electric field will apply force in this direction. There must be one force in this direction. So suppose due to electric force, further dx portion of this capacitor moves, sorry, dx portion of the dielectric moves inside the capacitor, then the capacitance of total portion inside will be C plus dc. C we have already calculated. So charge supplied by battery will be dq. So capacitance, increase in capacitance is dc. So dc times V. Now work done by battery. Suppose work done by battery is denoted as dWB. So that will be equal to V times dq, and dq is dc times V, and V is already there. So it will become dc times V square. Now, external force will do some work in the movement dx portion. So, work done will be work by external force. Must will be F dx, but it will be in opposite direction. So, total work done, or we can write it as minus F dx. So, let's write it opposite in nature. So, total work done will be sum of the two, that is work done by the battery plus work done by external force. So that will be dc times v square minus f dx. Now this work done must be equal to increase in energy. So 1 by 2, increase in energy will be 1 by 2 into increase in capacitance dc times v square. So it will be equal to this much. So dc times v square minus f dx. We further simplify to get f. So f will be equal to 1 by 2 dc times v square divided by dx. And we have c as this much. C we have found earlier as epsilon naught v divided by d times L plus x times k minus 1. Now, we have to find out dc from here. It means we have to differentiate it. So, dc will be equal to epsilon naught b divided by. So, here it can be differentiated with respect to x. So, let's find out dc upon dx. So, epsilon b upon d, b upon d times this will become 0 and x will become 1. So k minus 1 will be left. So we have got dc upon dx. Here we have dc upon dx. We can put this value epsilon b upon d times k minus 1. So f will be equal to 1 by 2 v square times dc upon dx is epsilon naught b divided by d times k minus 1, which is our answer. Thank you for watching.